Hello, this is the Tepid Coder. I want to follow up on my video about recursion that I did because I didn't get to touch on everything that I wanted to in that video. There was a bit of a debugging fiasco when I did some arithmetic operations in the wrong order. I tried to take the remainder of something that had already been divided and truncated, so that wasn't going to work out too well. Anyway, I want to show how this can be packed into 1/8 the size. So, conveniently, each of these is 8 bytes long. There's 8 bits in a byte. So, C++14 introduced a new syntax you could do to represent an integer value as a series of bits. It's 0b, and then you just do zeros and ones afterwards. So, I'm going to do that. You can also, in numbers, you can put an apostrophe as a digit grouping. Kind of like comma when you're, I don't know, say you're writing something like thousands, right? For every 3 digits you can put a comma. In C and C++, you can actually just put these wherever you want. It doesn't really matter. Anyway, you can do that with binary too. So that's kind of nice. So I'm just going to use this syntax real quick to my advantage. Okay. And then we're going to do it over here, 0b. Okay, let's do 0b here. Oops. Yep. Okay, one more. Alright. So now what we have, instead of this being this being 6 rows by 8 bytes per row, instead it's just 6 rows. So we've saved quite a lot of space there. We've reduced the size by 8. Now, of course, that means we have to do this a bit differently. Instead of saying we want the x position as the byte plus the row number by getting the number of bytes in a row times the y position, it's literally just the y position. That's the byte we're accessing. And the x is going to reference the bit within that byte. So I'm going to say and 1, and we're going to shift it left by stx, except I need to subtract it from 7. And that's because when I'm writing this, you can imagine this as being like the 1/28th place. 1/28th, it's hard to say. This would be the 64th place, the 32nd, the 16th, the 8th, the 4th, the 2nd, and the 1st place, the 1's place, right? And essentially, if I were to look at 1 and shift it to the left one at a time, I'd be writing it right to left. So I'd actually be using the reverse of the image. If you can imagine this being a picture with a bunch of white and black dots. Here's being black and the ones being white. So it would actually go this way, right? Like that. So what I'm actually doing is I'm saying start here and mask this bit. And keep masking progressively lower bits. And I'm starting with a 1. The value 1 is right here. In binary, it would just be that right there. And if I shift it left once, it's going to give me this. If I do it twice, it's going to give me that, right? It's just going to keep going this way. So essentially, I want to start here. And you can imagine if I'm starting at 1, and there's 8 bits, I can add 7 to it, shift over 7 times, right? So 1, 2, 3, 4, 5, 6, 7. So that's why I'm starting at 7. 7 minus 0 is 7. That's the first iteration. Now, it doesn't quite get to 8, because if it's 8, it stops. So it stops at 7, and 7 minus 7 is 0. And, well, 1 shifted to the left 0 times, it's just going to stay here. So what I'm doing here is I'm saying start right here, and progressively go this way until we reach the final bit. So I'm going to read it from most significant bit to least significant. It's most significant because it affects the value the most. Because, like, say this bit's set, and the rest are 0, that's the value 128, you know? And if this bit's set, that's only 1. So it's more significant in that sense. Okay, so let's try and actually run this. I'm going to go over here, sage plus testctp, so test. And it looks like it still works. So I saved 8 times the space, or I'm using 1/8 of the space. So that's pretty good. Now, another way you can do this, if you're not using C++14, and I don't think C supports this 0b syntax either, is you could do this. I'm going to say, let's call this 1. I'm just gonna, I don't know, I'll call it test or something. I just want to back it up so I can do a comparison later. Let's see, uint 8t, UI8 array, we'll call it picture. In this case, it's also going to be 6 bytes. I'm going to make the same thing again, but I'm going to do it with hex. With hexadecimal, you can do 0x, and any digit will be, 0 through f. So 0 through 9, and then A, B, C, D, E, F. Now, when I'm doing this, what I'm thinking about is nibbles, right? The first 4 bits is the lower nibble. The second 4 bits is the upper nibble, the higher nibble. And you can imagine this being the ones place, the twos place, like I said, 4, 8. So I'm actually going to add these. And for each 4, I'm going to use 1 hex character. So this one right here is 0. It's all zeros, so it has to be 0. This one over here, it's all zeros, has to be 0. Okay, that covers the first line. The second row, it's got 0, 0, 1, 1. Well, that would be 3, because I have a 1 and a 2. 1 plus 2 is 3. So 0x, 3. And what's after that? We have an 8 and a 4, which would be 12. Well, if we stop at 9, here's 8, there'd be 9. And then this would be 10. Both these is 10. Right? Am I wrong about that? Let me think about that for a second, actually. We have 1, we have 2, we have 4. Yeah, 8 and 4 is 12, sorry. Mine's not working right now. Okay, so if A would be 10, we have 0 through 9, then A, B, C, D, E, F. Then, let's see, we have 10 for A, we have 11 for B, we have 12 for C, and then both these over, wrap over into this, and have both these set would be D, I believe. So I think it's 3D. Let me think about that. So I have E, this would also be set. No, that's wrong. It should be C, right? For 12. Well, if A is 10, B would be 11, C would be 12, yeah. I should just memorize these at some point. I can't count, apparently. I'm trying to think of, the number and then the letter. So it's A10, B11, C12. I can't keep them both in my head at once. It'd be easier if I probably just wrote it down, made myself a little map to look up or something. Anyway, on this end we have 1, 2, 4. So we have a 4 right here. Okay, 0x4. And then what's next to that? We have another 4. So it's 4, 4. Now we're on the 4th line over here. We have a 4 and we have a 2. So 0x, 4, 2. And we have 0x. What's this one? This was the 4, 2, right? Yeah, okay. Then we have 2 and 4. So 2, 4. And 0x, what is this one? It's a 1 and an 8. Okay, so that should be the same. Now there's a function we can use to check to see that they are the same. We say if not mim compare, and we're going to compare UI8 array picture test is the one we're testing it against, and UI8 array picture. This is the one we're actually going to use now instead of this one. And we're going to compare 6 bytes. So mim compare returns 0 if they match, kind of like string compare. So if not mem compare, this returns 0, it's true. So if not that, it means they did match. So they match. Okay, otherwise we can say else they don't match. So let's try that and see what happens. They match. So I did it. I have an exclamation mark and a period there. That's kind of silly. Okay. I did it over here too. Jeez. Okay. Anyway, maybe I struggle with that a little bit, but you can do it both ways. You can pack things into hex. So probably some homework for myself as well as you guys. Is to maybe memorize this. Right, and then we have 1, 0, 0, and then 1, 0, 1, 1, 0, 0, 1, oh, sorry, 1, 0, 1, 1, and then 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. That should be 15 values, right? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Yeah. So really, I just need to memorize these. If I memorize those, I could have done that really quickly. But I had to keep saying, okay, well, 8 is 10, and 10 is, whatever, and then I'd get to it. But that's kind of cool, because no matter how long the number is in binary, like say we have like, right, and then something like that, you can find the hex for it just by breaking each one of these into it. So this would be A, and this is 2, and this is, what we have, well, I can look at the map right here I made. It'd be D, right? D, and over here would be an F, and over here would be a 2. So if I put it together, there we go, there's my number. So, I don't know, that's kind of cool. I should really make myself memorize these. If I can just look at these and know right away, then that'll help out a lot. But I also don't need to, because I have this. Well, if you found this helpful, then please like, comment, and subscribe. And if you didn't find it helpful, maybe give me some feedback on what I could do better, or maybe some things I missed. I definitely appreciate any kind of feedback, whether it's critical or whether it's, I guess, celebratory. Well, I'll catch you all later.